Good morning, everyone. We're going to be talking about the water resources in the Maputaland coastal plain. This is a project that it's an accumulation of quite a lot of work that has been done in different places. Just to give you the background, Maputaland coastal plain, it's the area bounded by the Lubombo Mountains here and the Indian Ocean. So to start with some of the case studies that we have. Very recently there's been a study on the western shores of St. Lucia by student Brights, who's published or produced a thesis in 2013. She looked at a number of different sites there. This is now results of one of the sites that she's been looking at. It's an area that was under pine trees and then was transferred to eucalyptus trees. Eucalyptus trees have very much deeper rooting systems and then much faster sort of growth rate, much faster rotation. The rotation is sort of about 7, 8 to 10 years that they cropped. Okay, what we have at this site that we're talking about is a reduction in 20 meters of the groundwater. Some of that reduction can be explained by drought conditions, but this is over a 15-year period when it was not all drought. So it's 20-meter lowering of the groundwater table in that period. This graph of hers shows the reduction in the groundwater table. That's the brown, the blue lines here. This shows the actual rainfall in the period, so that there were significant rainfalls that were happening there. Okay, so that's one case study. Then we start looking at the eastern shores of St. Lucia. In its sort of farsightedness, the St. Lucia Scientific Advisory Committee, SCADCO, set up a system of boreholes and groundwater monitoring in 1972. This is the central part of the eastern shores, showing these groundwater installations that we have. The black are the plantations that were planted in the 60s. The greyed out area of plantations planted in the 80s. And the first study was Wildlands, who looked at some of the results of this monitoring that was being done. The adjusted levels, so that from a number of these boreholes here, for instance, probably these three here, to show the impacts of a drought period that was going through. This is a 2-year timescale. The drought period lasting showed that the swamps showed very little change in water table. The grasslands showed more of a change, and the trees were much more thirsty, and that's where there was a much greater drop in groundwater during that period. Using the same data set, but accumulated now till 2010, Lars Varet from Norway did a very detailed hydrological model of the system. And using that model, he simulated what the impacts would be of different types of land uses. The big conclusion is that land use changes are far greater than predicted climate changes on the system. You know, we have this bandwagon about climate change and all that. It's actually the local change in land use that we need to take much more concern about. Then in the Twin Streams project at the CIA, this was set up in the 1980s by the Natal Town and Regional Planning Commission. It was on the farm that Ian Garland's farm. It's a farm that has two different stream catchments, more or less the same sort of a size, both of them with perennial streams, and gauging weirs were put on these streams. So there's the Manzanyama gauging weir and the CI gauging weir. So these weirs are over here. And this has been tracked since then. Now, what happened in 2000, before 2000, the catchment area was virtually all under sugarcane. In about 2000, the land use changed. The farm changed hands. It was converted to a forestry area. 25% of the CI catchment, 26% of the CI catchment was put under eucalyptus, 66% of the Manzanyama was under eucalyptus. So these are two catchments that have been responding fairly in a similar way until that period. This is the important graph of this one. Let me just explain this a little bit. This yellow line is the important one for rainfall. It is cumulative rainfall. It is more or less linear, showing that there hasn't been any sort of major change in the rainfall pattern at all. There are little bumps in it that as one goes through droughts and so on, but it's basically a linear line. Before here, there was no forestry. After this blue line, there had been forestry put in. If you look at what happened in the CIE stream with a quarter of the catchment under eucalypts, at about this point there was an inflection change, but there were still flows in that catchment. In the Manzanyama catchment, again, this is the graph. At that point when the eucalyptus trees were put in, from then onwards there have been no perennial flows in that river. It has only been sort of storm flows that go through every now and then. More recently, Bruce Kilby and myself have been working in the Ntlabane catchment. This is now near Cape St. Lucia. This is an aerial photo 1937 of the catchment. It's basically the yellow sort of spiderweb of sub-catchments that are used for modelling here. Part of this area, bounded by the red, is subsistence sort of agriculture and use of the area. 1937, this is the 1937 photo. There was no forestry in the area, and since then there's been this exponential growth in forestry. In about the late 50s, 60s, the commercial forestry was initiated. Excuse me? Hey? And then after that, it became a small-scale woodlot subsistence type forestry until we've got the point where we've got about 70 to 80% of the catchment covered in trees at the moment, almost all eucalyptus. This just is another picture of that same story. You can see this is the commercial forestry, this area here. This is the subsistence area with forestry. The yellow-green is the open areas. Basically, we've got 80% of the total catchment is now under eucalyptus, and the expansion is continuing. As areas dry up, they are being planted to trees, woodlots, and so on. And also there's been chopping of indigenous forests to put into to eucalypts again. And with that also there's this uncontrolled increase in alien plants. If we look at the monitoring of this catchment, there are two key boreholes we need to look at. This one in the top area of the catchment where water level's been dropping at over a metre a year for the last several years, for the last 8 or 9 years. We look at a borehole right on the edge here. The borehole level has been virtually sort of static. That's not affected by trees at all. There's another borehole here. This one here, which is just outside the catchment here, which is actually affected to some extent by the mining activities, which actually subsidize the water supply there. The key take-home message from the Ntlabane catchment is we did very detailed groundwater modelling there. Since 1976, the rivers have stopped flowing. This is the decline in the rivers here from 100,000 cubic meters per day to nothing, except for the occasional storm flow in those rivers. So that's the story of Ntlabane. This is a case where there's been rampant expansion of forestry, the woodlots, small-scale forestry, as well as the older commercial forestry. So, this is the story of Ntlabane. This is a picture that was taken about 8 or 9 years ago, just showing all the small-scale forestry. It is much worse at the moment. This has caused a loss of grazing, a loss of agriculture, a loss of water supplies as the wells and streams dry up, a loss of indigenous biodiversity, and resulting in that is displacement of people. Okay, the Ngobeseni catchment is up Sudwana, where we are working at the moment. This is a project funded by the Water Research Commission. The key people in the project are myself, Bruce Kilby, and Guy Bate. And we're looking at various aspects of how the hydrology is affecting the ecology, the linkages between hydrology and ecology, and what sort of future trends we can sort of pick up in this area. The key places are Lake Shazibi, Lake Ngobeseleni, the small Ngobeseleni estuary here. The land use map in this area here, this is Mbazwan, this is the red area here. It's sorry about the quality of this map here, but it's done as part of a modeling story, so it's broken into pixels. This is Mbazwan, the heavily inhabited sort of urban area. The black dots here are the homesteads in the rural area. We get the forestry area here, these are the forestry plantations. And we get the conservation area here, which is uninhabited. The population growth has changed from very, very low in 1950s to about 6,000 people in this area now. This is a catchment of about 8,000 hectares. The simulations, or the model simulations that we've got looking at this land use pattern here, show what happens if there are no plantations or with plantations. The white in this map is areas where the water table is within 5 meters of the surface. You can see how in the forestry area this has declined down to below, it's dropped by about 10 meters from what it was due to the trees in that area. Okay, so from these case studies, what we're really learning, which I think is something that we know, but we now have the science behind it, plantations and woodlots are damaging the water resources of the coastal plain. Now, what is the sort of the future? What holds with forestry expansion? If you look at this here, this is the southern area of the coastal plain. That is virtually full up now with forestry. There's not very much room for expansion. In the northern area, north of St. Lucia, Water Affairs is sitting on a whole lot of license applications. There's a moratorium on them at the moment, but they are also just sort of saying, well, at some stage they've got to consider those applications. They commissioned a study from Northwest University, it was Ingrid Dennis and a few others, who made the statement that there should be no afforestation within 5 kilometers of sensitive wetlands, not without intensive hydrological research. And there should be minimal abstraction or afforestation, because forestry is the same as abstraction, taking water out of the system, in the vicinity of lakes, Ngobesaleni, Sabai, Kosi, and so on, without detailed studies. So if you take this and put a 5 kilometer around Lake Ntlaban, the whole catchment virtually falls within that area. So one can't really change that. If you take the Ezemvelo Park and put that 5 kilometers around it, there's already a lot of forestry in a lot of places within that 5 kilometers. But there's also the potential for a lot of growth in that forestry. If you look at the Mbazwan Sudwana area, this here's just a scale bar of 5 kilometers. This is the boundary of the Ezemvelo Park. You can see the commercial forestry here, a lot of it is within 5 kilometers, and you can see the woodlots starting to grow and grow and grow, many of them within that 5 kilometers. If you look at the Manguzi Kosi area, this is the boundary here, this is the Kosi Lakes here, this is the 5 kilometer scale bar, you can see these forestry areas going within that 5 kilometers. So forestry development, the development of forestry in areas recognized as a stream flow reduction activity, and it's thus regulated by the Water Act of 1998. Water Affairs recognizes the threat, I believe, to the coastal plain from uncontrolled deforestation, but it does seem to be reluctant to enforce the regulation because of the social pressures. So these are short-term social pressures. They're not taking into account the longer-term social pressures, and they're different pressures. Short-term, people want trees because it's an income. Longer-term, they get displaced by the trees because they are damaging the environment. Okay, so this is basically where we are at the end here. The uncontrolled expansion of forestry in the Ntlaban catchment has degraded its water resources. That has, it came out so very strongly in our case study how important that it seems to be an uncontrolled sort of expansion all the time. The concern is that this could happen in the Kosi, Sabai, and Ngobesaleni catchments. The story is that water resources have to be managed with integrated planning. It doesn't seem to be terribly much of this. And really this presentation is just to say that there is now a substantial body of scientific knowledge to show that can be used in this planning, that can help with the going ahead in the future. Thank you.